One very serious hazard for pilots is that moment when your eyes, your body, and the seat of your pants are telling you something completely different than what your plane is telling you. I mean, you can get thrown off, especially when you need to make a crucial decision, like when you're landing. Can we train the mind and body to work together to handle these intense situations? Maybe Dr. Scott Wood could tell us. Come on in. Doctor, how you doing? Hey, good to see you. So, tell me, what do you do here to keep these astronauts cool?
Oh, you know, we're just getting ready to start a study. Why don't we show you in the next room?
Let's go. Let's go. So what do we have here?
What we have here is a motion simulator that we've used with pilots and some of our returning astronauts.
Okay.
So it's creating some of the confusing, challenging sensory conditions that pilots experience.
All right.
And what we're really excited about is some of the new sensory aids that we've been looking at. Actually, this has been developed through some research in the Navy. And the point is, sometimes when you're in these challenging situations, it's not that we don't have enough information for the pilot in the displays. Sometimes it's just grabbing their attention, having them pay attention to it. And that's the point of these tactors. So these are small little pager motors. They're right here. And what they do is they vibrate.
So wait, let me clarify something. These are sensors. So, I mean, when it's strapped on the body, if the pilot has to go right, they will feel like a vibration on the right side of their body.
That's correct, yeah. That's their feedback. It's kind of like a tap on the shoulder just to get their attention and let them know what direction they need to correct.
Very cool. And you said you have Julie helping us out today?
Yeah, so Julie's going to wear these and get in our motion simulator.
You're braver than I am, I'll tell you that.
Okay, Julie, now we're going to try that with the tactor feedback.
So what are you having her do, Doc?
We're having her controller position so as the computer moves the chair off axis, she's trying to keep herself centered, similar to a pilot trying to keep their aircraft hovering in the same position.
I am so glad that's not me.
Ever notice that anytime you're thrown off balance, the first thing you want to do is to get some solid footing? Well, your feet know where to go because you know which way is up and you know which way is down. You can do that because of something called the vestibular system. Now that's the system that sends signals from the inner ears to the eyes to the muscles that keep us upright. Most of the time, the vestibular system does its thing without us ever having to consciously think about it. But guess what? In space, in the free fall of microgravity, there is no up and there is no down. And that throws the vestibular system way off. In fact, it makes some people physically ill. It's a little something that folks here at NASA call space motion sickness. But researchers think with a little training, astronauts can actually use their minds to overcome their body's desire to, well, you know.
It's true. Space motion sickness causes problems, but NASA is now working on additional training for astronauts before they fly, and this is where that'll happen. This is Deborah Harm, and she's working on ways to prevent space motion sickness. How are you?
Good, how are you?
Good,
Nice
good to see you. My pleasure. What do you call this thing?
Its official name is DOME, which is an acronym for Device for Orientation and Motion Environments.
Okay.
But most people just think of it as a big virtual reality training system.
Cool.
And we're getting ready to test someone. Would you like to come in and see?
Sure, let's check it out. Okay. And I hope I don't get sick. Oh, wow. This is neat.
Full immersion virtual environment system.
Totally. When does space sickness often occur? On the way to space or throughout the mission?
It doesn't occur throughout the mission. The biggest time for space motion sickness is in the first 24 to 72 hours on orbit, and then again upon return from spaceflight.
Oh.
So, and any time you change the gravity conditions, there's likely to be some motion sickness.
Can we fire this up?
Yep, it's ready to go. We just have to show her how to use the space ball, and she can fly through the station.
Well, while you're showing her, I'm walking out. You guys do what you gotta do. Deborah, that was awesome. Thank you so much for everything.
You're welcome. It was my pleasure.
Talk about mind over matter. Jennifer. Okay, so we know our vestibular system is what keeps us upright and balanced here on Earth. And that going into space completely throws it out of whack. But did you know that when you return from space, your vestibular system stays out of whack for up to a few weeks? Well, we can't have astronauts stumbling all over the place. So guys like Dr. Jacob Bloomberg here have devised training techniques to help astronauts readjust to Earth. How you doing, Doc?
How are you?
Good to see you. Why do astronauts have such a hard time readapting to Earth?
Well, the human brain is remarkably adaptable and adapts to the zero-G environment of space. The downside of that is when you return back to Earth, you need to readapt to the Earth environment. And that can even take up to several weeks at a time.
Wow. So, Doctor, tell me exactly what's going on here.
Well, during this training, subjects walk here on the treadmill, and while they're walking on the treadmill, you can see that the visual scene moves up and down, and also the walking surface moves up and down too. And what this provides is a balanced challenge while you're walking. And this trains the brain now to become more adaptable to deal with some of these challenges. So you get better at dealing with it over time.
This is great for astronauts. What about Earth applications?
Well, falling is a real big risk factor for older adults, and we've been using some of this training to train older subjects to become more adaptable. So we think that'll prevent them from falling in the future. So we see some really widespread applications for this type of training.
Well, Doctor, this is giving my brain and body a workout. Thank you for everything.
Absolutely.
Awesome. Listen.